Yeah, hello and welcome to this video on roads and houses puzzle. So I'm going to show now how it works. So this is an explainer on what you need to do to solve it. So then there is another video on how to actually solve it as an example in Python. But the roads and houses problem is something like this. You have a grid and roads and houses. Gonna focus on those two objects. So basically each part of the grid will either be having a road or a house. And this bottom left square there will always be a road. And then the objective of this is to maximize the number of houses. And if I were to just have the bottom left as a road, then we would get a house there and there. So the rule is that any square which is not a road and that borders on a road that leads back to the bottom left corner gets to be a house. So in this case it would look like this. If we would start to draw some roads, let's say we draw a road here. So we have this situation. Then we'd get houses all over the road and also under the road, like so. And if we were to remove just the last part of the road here, then we would lose some of the houses as well. We'd lose this house, and instead we'd get a house here. So these diagonal squares, they will remain empty. So it's only orthogonal or cardinal directions that are counted. So in this case, we'd have 3, 4, 5, 6, 7, 8 houses. But the objective is to maximize the number of houses in the whole grid. If we now switch to our interface here, you can also try it out manually to get a feeling for the rules. So if I press, this is the smallest level is 4 wide, 3 high. So if I press interact, I get to try to draw roads. It starts off with those two being houses like we showed. And if I draw a road like this, then we're at 7 houses. And as it says here, this is the optimal result. So then we should be happy. So we can stop the interact and go to level 2 and start over here. So how do we then optimize? Well, you can do it in different ways. We can start to draw some kind of spiral here maybe. Okay, that was actually optimal, so that's nice. By the way, to clear, I just draw these guys here and I clear those rows that I drew. So we can solve it in many different ways. Just trying to show you a little bit of the rules. This one is done 5 by 5. If we jump to level 3, we can go into interact up there. And here we can maybe try some different ways to do it. Let's try the spiral thing again. If we do it like this, maybe. And there we have the optimal results. We are at 28 houses. So this is one way to do it. In level 6, there is a huge one, which is 13 by 13, and so forth. So you can try it out manually and try to find the best solution, like I showed. But if you now focus on the programming side, you have instructions here to the left. And the solve method that you get looks like this. This is Python example. If you change to C#, you get C# code here. If you change to Java, etc., you get a starting code for that language that you have chosen. But we're going to go with Python as the example here. Here I have some code, but now let's focus just on the interface. So you get the width and the height of the drawing field, the playing field as input. And then what you should return, as it says here, is a list of booleans. So it's like a matrix. So in this case, when I initialize it in Python, for example, it could look like this. We initialize it with false, false meaning it's not a road. And it's width, and that one times width. So it's the inner list is as long as the width, and the outer list of such rows is as long as the height. So that's the starting positions. For example, in this one, which is 4 by 3, what you're going to return looks like this. It's a double list or a matrix. And yeah, in this case, we see false, 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 false. That's the uppermost row here. Then true, 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 true will be the row that we see here. And then true, false, false, false is the bottom row that we see here. So as you print your data structure with booleans, it actually corresponds very well to what you see in the interface down here. And I also want to point out something else. If you go into the interface here, there is a button called X, Y. You can actually go to, let's take level 3, level 2 even, and reset it. And then we can click the XY button here. Let's stop interact. So the XY values shown show the top one being 0, 0. So X value 0, Y value 0. And here is 1, 0. So X is 1, Y is 0. And so forth. And then if you go down row by row, the Y value increases from 0, 1, 2, 3, and so forth. And one thing which might be confusing here is if you to translate these XY indexes that you see here to the data structure you have when you create this grid here, then it will actually be accessed like this. So grid, and the outer most index is Y and the inner index is X. So the outer index corresponds to the column and the inner index corresponds to the row. So for example, in this case here, grid of 2, 0 will be the bottom left corner, which always starts as a row, as we explained before. One thing to mention also is that there's only 2 values that you send back in the grid. It's a boolean, so it's false or true. False means that it's not a road, and true means that it's a road. So the houses you don't send back, those will be filled in for you. So if we take this level 2 here and we just return, yeah, we can have this grid here, and then we just set some value. We can set grid of, what should we take? Let's draw a road here. So 0, 3 means we should set grid 3, 0 to true. And then I'm just going to return that. So now we want to draw a road just from the starting position, which is always this one, and one step up. And we're going to see how the houses are filled in for us. So let's run code. And now I actually forgot to set, this is an illegal one. This one needs to always be a road. So we should also set 2, 0 to a road, like so. Oh, sorry. 4, 0, I mean. This is 5 by 5, yeah. So this would be a valid configuration. Actually, I should have a warning there in the system if you try to draw an illegal road like that. So we would send in these 2 as roads, and then the system fills in the valid houses, like so. And just to give another example of how this works, if I were to draw an illegal, or not really illegal, but if we draw a road at the top left corner, it will exist as a road, but there will be no houses around it, since it doesn't lead back to the bottom left corner. That was another rule. There's only a house placed if it's sharing a side with a road, and that road leads back to the starting square bottom left corner. Of course, only orthogonal moves, no diagonal moves. So yeah, there's no house here as well. So that is basically the problem. If we go back into interact mode here, let's take level 4, for example, just to give you an idea of a possible solution. It's very, very hard to solve this using a tree search, as is the case in many of our problems. The tree search is really nice. But in this case, maybe you can do something like this. And yeah, maybe find an algorithm to draw something like this. This is an optimal result for this level 4, for example, which is 9 by 9. Yeah. So trying to give you an idea on how to solve it here. There's also a solution video which you can check out. So good luck in solving the roads and houses puzzle.